What's up, geometry students? We're diving into equations of circles. I need you to do this homework with Desmos. That way we can see if our answers are correct. We can double check things. It is going to be very important that you see your work and it being correct. And what we're talking about is how all points, possible points that are a certain distance away from a center point is literally the definition of a circle. Okay? So all the points that are 5 away from 0, 0 would be the circle of points. And we realize that the connecting equation with distances in the coordinate plane is the Pythagorean theorem because we have horizontal distances that are theoretical, hypothetical, from 0 to some x would be a plus x or x minus 0. From 0 to y would be a plus y. And we realize that a squared plus b squared equals c squared is actually going to give us the equation of a circle. Plus x and plus y. And the Pythagorean theorem is going to be a squared plus b squared equals c squared. If I graph x squared plus y squared equals 25, we get the circle with radius 5. That includes the points that we would expect to have on the circle that are 5 up, down, left, and right from the center of 0, 0. Cool? But what if the center of the circle was not at 0, 0, is rather at the point 1, 2? Let's draw the right triangle to represent the horizontal distance and the vertical distance. Let's realize that from 1, 2 to the hypothetical point xy, to find this change from 1 to x, I'd have to add x and then subtract 1. Or the operation done to find change is subtraction. X minus 1 is the change from 1 to x. 1 plus x minus 1 gives us from 1 to x. Y minus 2 is the change from 2 to y. So that would be what I would consider the horizontal and vertical lengths. We can see that the radius, or this unifying distance, is 4. So we would be able to write a squared plus b squared equals c squared, and it would give us all of our hypothetical xy points that are 4 away from the point 1, 2. A squared plus b squared equals c squared. Now, we should see this point 1, 6. We should see this point negative 3, 2. These are just examples of like easy points that should exist on our circle. So if we went ahead and graphed it using Desmos, first thing is first, we have this x change squared plus this y change squared. So that's y minus 2 squared equals my diagonal length squared, or my radius squared. And what's a good thing to do is plot the center point 1, 2. Okay, good. That fits in the center. And all you do to plot points is just do shift in the parentheses. Plot maybe the point 1, 6. Yep, that fits. Plot some other points or try to check other points. Negative 3, 2. Yep, that's expected. So, boom, we did it. Okay? And now we were able to really develop a unifying equation for all circles. If you want to find a circle that is an r length away from a center hk and it goes to this hypothetical xy, well, from hk to xy, this x length would be x minus h. This y length, or displacement or change really, is y minus k. And we would get this x distance squared plus this y distance squared equals this radius squared. And most students memorize this, but I don't want you to memorize this. I want you to rather understand where these circles come from. Okay. So starting with this question, write the equation of a circle centered at negative 2, 3 that has a radius of 3. What are 4 easy points that can be found on the circle? And what is the equation of the circle? So this is going to be great to do on Desmos. So here's the important point. We have this point, negative 2, 3. We want all of the hypothetical xy points that are 3 away. So we have to always bring in this hypothetical xy point to be able to produce an equation of all of the possible xy points. And we have to understand the change would be the subtraction of x minus negative 2, or from negative 2 to x, it would be plus 2 and plus x. So x plus 2. And the change from 3 to y would be y minus 3. Add y to 3. You have 3 plus y. Subtract 3. You have y. So we went from 3 to y. You subtract. And then the equation of all of our possible points would be our x distance squared, or x displacement squared, plus our y displacement squared, equals our radius squared. Great. Let's graph it so that we can see our handiwork. Make sure we're correct. X plus 2 squared plus y minus 3 squared equals 9. We have the center of negative 2, 3. That works. We should always check that our center is at our center. And then, what would be the 4 easy points? Well, we could go up 3, down 3. So up 3 would give us negative 2, 6. Down 3 would be negative 2, 0. Left 3, right 3 would be adding and subtracting 3 from the x. So I'd get 1, 3, and I'd get negative 5, 3. We could also plot all of these points. Negative 2, 6. Negative 2, 0. Great. 1, 3. And negative 5, 3. And it's like, this is it, guys. This is what we want to see. This is what Desmos allows us to do, is check and make sure the points that we expect to be on our circle are. And the other points are harder to find. They could be found, but they're harder to find. Okay? Great. Some questions will get more difficult. Cool. Write the equation of a circle centered at 0, 4 that has a radius of 6. Cool, so I'm going from 0 to 4 to a hypothetical xy. So 0, 4 to a hypothetical xy that has a radius of 6. The uniting equation is the Pythagorean theorem. X minus 0 is just plus x. Y minus 4 would be the x change and the y change. Then I'd have a squared plus b squared equals c squared. Cool? And 4 easy points that I would find that are 6 away would be 0, 10, 0, negative 2, 6, 4, and negative 6, 4. All right, double check. Cool. Do we center at 0, 4? Do we have the point 0, 10? 0, negative 2? 6 from 0, 4. 6, 4. And negative 6, 4. Yep. It's beautiful. It's a beautiful sight to see. Beautiful sight to see. All right. But things can get harder. Let's change this from that to this. When I'm not giving you all the information, maybe I just give you the center and a point. Well, you got to do some work for me. you need to find the radius. You need to find this diagonal distance. And then you need to think about having a hypothetical point. So we can get the collection of all points. I'll show you where everybody makes a mistake. So first, what is this radius? Well, we got to use the Pythagorean theorem to find the radius. So 3 to 1 is minus 2. Negative 1 to 4 is plus 5. So I got a squared plus b squared equals c squared. And I get 29 is c squared, or c is the square root of 29. Yuck. Yuck. But that's what it is. It's the square root of 29. That's the radius of the circle. We call it a radius. That's the distance from the center to the outside. Cool. But now, this is the important thing, is we got to break out Mr. Hypothetical xy that exists on the circle. That is root 29 away from 4, 1. And we got to go with this 4, 1, the center, to this hypothetical xy. This is where students make mistakes, because a lot of students will go and just type in the negative 1 minus 4 squared plus the 3 minus 1 squared equals c squared. And it's like, nothing happens. Yeah, of course, nothing happens. Because we want the hypothetical x, y. And is that even right? Yeah, that's right. So we change the negative 1 in our equation to our hypothetical x. We change our 3 in our equation to the hypothetical y. Or we understand that our displacement from 4 to x is x minus 4. Our displacement or change from 1 to y is y minus 1. And we have x minus 4 squared plus y minus 1 squared equals the radius squared. And this is something that we might not understand, that root 29 times root 29, or root 29 squared, is just 29. Okay? Whether you have root 29 squared, or you know that root 29 squared is 29, you're good. Now, what we're going to do to check is plot the center. Does it look like it's in the center, or can you understand that it's in the center? And try to visualize that point negative 1, 3. And is it where it should be? Which it is. This is how we check our work. Make sure things are correct. So this equals c squared, or root 29 squared. All right, you guys should do this by yourself. The center is at negative 1, 3. It contains the point 1, 0. We need to find this radius. We're going to use the Pythagorean theorem to find the radius. We have an a squared, which is 4. So negative 1 to 1 is plus 2. B squared is 9. Negative 3 squared is 9. Excuse me. Equals c squared. So 13 is c squared, which means c is the square root of 13. All right, so that is the radius that will unite all of our points. Now we break out our hypothetical x, y. That is going to be root 13 away from negative 1, 3. So here is negative 1, 3 that will travel to xy using a distance of root 13. From negative 1 to x, that change is x plus 1. From 3 to y, that change is y minus 3. X plus 1 squared, a squared, plus y minus 3, b squared, equals c squared. Root 13 squared is 13. Double check if you are able to by plotting the point negative 1, 3, which is the center. Plot the point 1, 0, which is this point on the circle. Let's change our equation graphed to be a squared, which is x plus 1 squared, b squared, which is y minus 3 squared, equals c squared, which is the square root of 13 squared, or is just 13. And we have our point 1, 0 on our circle and our center at negative 1, 3. So x plus 1 squared, y minus 3 squared equals 13. What if I give you a diameter? Well, this is where we have to think about what is the definition of a circle. Well, it's all points that are equidistant from a center point. If I give you a diameter, you don't have the center. You have to find the center. How do you find the center of a diameter? Well, it's the midpoint. We've done midpoints before. We go from -5, -2 to -1, -2. Well, there's no y change from -2 to -2. So the y coordinate of our center is at -2. And from -5 to -1, that's a +4. I'm going to add 2 to get to -3. I found my center is at -3, -2. Now, how do I find my radius? Well, guys, we actually don't need to use the Pythagorean theorem to find our radius because we can see that this is a horizontal length, or we know that we have a horizontal length because we have -5, -2 to -1, -2. -3 to -1, -5 to -3 is just 2. So our radius is just 2. And now we can break out our hypothetical xy. Yep. Geometry. Did you do your homework for me? How's it going? Okay. Well, I'm here to help. Cool. So we have the displacement from -3, -2 to xy. The change from -3 to x would be x plus 3. So like add 3, add x, and you get to x. From -2 to y is add 2, add y, or y plus 2. Or you can think of like subtraction to find change. And we got a squared plus b squared equals c, which is the radius, which is 2 squared. C squared, 2 squared is 4. Now I should graph this and make sure I have the points -5, -2, and -1, -2. So I got x plus 3 squared. I got y plus 2 squared. And I got 4. And I should see the points -5, -2, and the points -1, -2. And 2 other points that work, and we're good. Okay, what if the diameter's on a diagonal, though? Well, then things get a lot trickier. This is probably the most involved problem, where you're given the diameter, and the diameter is a diagonal. We have to find the middle, because the middle will be the center of the circle. So, Mr. Midpoint, from 4 to 6, that's an add 2. Well, I'm going to add 1 to get to 5. From 7 to 3, I'm going to subtract 10. We'll subtract 5, and I get to 2. And I have my midpoint is at 5, 2. Great. Well, now I need to find the distance. Now, you could find the distance of the entire diameter and then divide it by 2. But I would rather just like find the distance from the middle to the outside using the Pythagorean theorem from 4, 7 to 5, 2, or from 5, 2 to 6, -3. So from 4 to 5 is a +1, from 7 to 2 is a -5. And I will have a squared, 1 squared plus -5 squared. So I have 1 plus 25, which is 26, equals c squared. C will equal root 26. Cool. Great. Now we have our center. Now we have our radius. Now we break out our hypothetical xy. Or we use our triangle with 5, 2, xy, and root 26, which can't be simplified. But if it could, I actually don't really want to, because the equation of a circle involves c squared. So I have from 5, 2 to xy a change of x minus 5 and a change of y minus 2. I got x minus 5 squared plus y minus 2 squared equals root 26 squared, which is 26, or root 26 squared. I'm going to graph and make sure I can see it. X minus 5 squared, y minus 2 squared equals root 26 squared, which is 26. I can see the 0.03. That's nice. But I'm looking for the 0.47. So 47 is on the circle. I'm kind of clicking on the circle and dragging to see if we can find it. I'm wondering if there's an ability to trace. This is for you, Leo. I'm wondering if there's an ability for you to trace around the circle and get to a specific x coordinate or a specific xy coordinate. So we can investigate further. We can also plot 4,7 and maybe see that 4,7 is on the circle potentially. We can look at 6, -3, make sure that is on the circle by tracing around it somehow, and see that 6, -3 is on the circle, just as a way to check. But if you're confident in your abilities, then you're good. All right, a circle has the equation x minus 4 squared and y plus 5 squared equals 16. What is the center of the circle? What is the radius of the circle? Great question. So this is a squared, this is b squared, and this is c squared. So we can see if we're going from 4 to x, that would be an x minus 4 change. If we go from -5 to y, that would be a y plus 5 change. I've just kind of discovered that my center is not at -4, +5. Rather, it's at +4, -5. What is the radius? Well, the c squared is 16, so that means the c has to be 4. Now, what's another way to do this? I mean, if I'm allowing you to use Desmos, graph it. X minus 4, y plus 5 squared. X minus 4 squared, y plus 5 squared equals 16. You can see that the top is at 4, -1. The bottom is at 4, -9. Well, the middle is 4, -5. You can see it's not at -4, +5. It's at +4, -5. You can see the radius would be half of our diameter. If you have the point 4, -9 and 4, -1, you can see that diameter is 8, which means the radius is 4. It's just like good things to do. And what about this guy? Well, I mean, like, let's graph. X squared, or x plus 2 squared, plus y squared equals 8. All right, now, here's the problem with this one. We got this diameter that is this weird length. It's this 2.828. 2.828. So we can see where the center is. We can see that the center is at -2, 0. And you could plot -2, 0 and see that that's the center. So at least we got that. -2 to x would be a change of x plus 2. 0 to y would be a change of just y. So there's that x plus 2 squared. So the center is at -2, 0. But what's the radius? Well, this is where we understand a squared plus b squared equals c squared. C squared is 8, which means c is the square root of 8. Watch. If I type in the square root of 8, I get that 2.828 number that we kind of saw at the top because we're going off of 0. So that is an unsimplified answer. Shout out to the old school mathematicians that had to simplify square roots to figure out the decimal approximation. We would want you to know that the radius, or this diagonal length, is 2 root 2. Okay? Good questions that we need to practice, and really just ties together with the stuff that we've been doing so far. See you out there. Engine Stinking next class. Peace.